Agam's lecture series, a series of lectures designed to bring learning to the comfort of your homes. Today we are still continuing with our subject, General Lab Techniques, GLT 111, Part 3. And we are going to start the physics aspects of laboratory techniques. The topic of discussion today will be laboratory cooling systems. We look at types of thermometers, and we look at electrical transmission, distribution, and connection. Now, we're going to start with cooling systems. There are various cooling systems you can get in the laboratory. The first one is refrigerator. What is the refrigerator used for? It's used for storage. You can preserve and store items in the refrigerator. We have air conditioners. Air conditioners regulate temperature conditions in either a room or in an enclosure. We have freeze-over. Freeze-over is used in dehydrating microorganisms by freezing or sublimation. We also have water circulation. This provides pump flow of temperature-controlled liquid through various apparatuses for cooling purposes. In a car, we have a radiator. You put water in that radiator so that this temperature-controlled liquid can be circulated to different parts of the engine so as to cool the engine. Remember, the topic is what cooling systems. Now, in the refrigerator, you put your materials inside the refrigerator. The refrigerator is hot. Then, at the back of the refrigerator are coils, and inside that coils are refrigerants, liquids that boil with little heat. Take for instance, if you go to the filling station, if a petrol touches your hand, very soon it will evaporate and your hand will feel cold. That's exactly what the refrigerator does. But what the refrigerator does is to remove the heat from inside the fridge, from the material there, and deposit it at the back of the fridge, so that the inside becomes cool and the back becomes hot. It's the heat from the inside that it deposits at the back of the fridge. The same thing that the air conditioner does. It removes the heat from the inside of the house and put it at the back of the air conditioner outside, so that the inside will be what? Cool. All these coolings, the important thing that there's a liquid that is volatile. At a little temperature, it will evaporate. So if you pour petrol in your hand, when you evaporate, you remove latent heat of vaporization from your hand, and your hand feels what? Cold. Now, what are the major parts of a refrigerator that will enable to understand how it works? We have an evaporator coil. The job of the evaporator is to evaporate the refrigerant. Refrigerant is the liquid that evaporates. To evaporate the refrigerant in the tube coil, just to evaporate it. And for it to evaporate it, you collect heat from the inside of the fridge. Then you have the compression pump. What is the job of the compression pump? It removes vapor from the refrigerator, compress the vapor, and pump it into the condenser. Because when the liquid evaporates, it will evaporate as what? Vapor. Now this compressor removes the vapor, compress it, and pump it into the what? Condenser. Then what is the job of the condenser? It condenses the compressed liquid. To condense means to change it back to what? Liquid. So that it can go back again and collect more heat, so that the cycle can do what? Continue. Then you also have a thermostat switch. What is the job of thermostat? It controls the rate of evaporation by switching the pump motor on and off at intervals. That's why, because you can keep your refrigerator, if there's light continuously, it doesn't start cooling. After some time, the thermostat will switch off. After some intervals, it will be on. Now, let's look at types of thermometers. A thermometer is a scientific device used to measure the degree of hotness or degree of coolness of a body or of a substance. In our local villages, our mothers touch our head with the hand to determine whether we have fever. But it's a subjective way of determining temperature, because supposing the woman's hand is hotter than the child is shaking, it cannot determine anything, because heat can only flow from an area of low heat to an area of what? High heat. So if you wanted the heat to transfer from here to here, and your body is hotter than that of the child, you cannot measure anything. Therefore, there must be an instrument whose job is to measure what? Temperature. And that instrument is what? Thermometers. And we have different types. We have one, liquid in glass thermometer. That means that for this thermometer, there must be a liquid inside a glass. And two major types of liquid are used in thermometer. One is mercury and one is what? Alcohol. The boiling point of mercury is 375 degrees centigrade, while the freezing point is 39 degrees centigrade. So you can see you can use it to measure very high temperatures, but you can't use it to measure very low temperatures. Then for alcohol, the boiling point is 78 degrees, but the freezing point is minus 115. So you can use it to measure very low temperatures. We've discussed before the advantages and disadvantages of both mercury and alcohol in measuring. Like this one, mercury does not wet glass. It's visible, you can see it. The alcohol wets glass, you must color it for you to see it. So this, they have advantage and what? Disadvantage. While mercury is costly, alcohol is what? Cheap. They all have different advantages and disadvantages. Then we have gas thermometers. So this one, instead of liquid in glass, it will be gas that will be in the glass. Then we have platinum resistant. This is an electrical thermometer. We have the infrared thermometer. If you go to hospital these days, they no longer use clinical thermometer. They use a digital thermometer where they just touch it on your head and it records the temperature. That's called infrared thermometer. They use it in most teaching hospitals and good government hospitals now. Then we have thermocouple, used for measuring very high temperatures in industries, temperatures that are beyond what thermometers can measure. Then also you have pyrometer, used for measuring temperature in furnaces. Furnaces like we have in Ajokuta, where temperatures range from 1,000, 2,000 and above. So these two are used in the industries. Before we have this infrared thermometer, which is more digital. What we used to have is clinical thermometer, which doctors use. They put it in your armpit or they put it in your tongue to measure temperature. Why? It's very sensitive because the range is just between 35 degrees centigrade to 43 degrees centigrade. You know the temperature, the normal temperature of a body is 36.8 degrees centigrade. So that before someone's temperature will raise, if anybody's temperature is already 37, they will quarantine you for COVID because your temperature is not supposed to reach even 37.1. But for your temperature to drop at 35, you're already dead. For your temperature to even reach 38, you're already dead. So the range is so small that is just the normal temperature already between 36.6 to 36.9. It doesn't even pass this range. So it's very, very, very short. And there is a special term for it called clinical thermometer. That was what was being used when this modern digital one, infrared thermometer, came in vogue. Then let's look at electrical transmission. Electrical transmission. We have electrical transmission. How power is generated from the generating plants like hydro dam, how it is distributed, and how it is what? Connected. So these three are the three we're taking on. Electrical transmission. When current voltage is generated, either from Kainji power dam or any other generating set, it is fed into a step-up transformer, which steps up the voltage for primary transmission. It steps up for primary transfer to transmit to long distances where it will start getting close to the consumers. This primary transmission is called high voltage transmission. It's called what? High voltage transmission, and the range is between 132 to 330 kilovolts. Then after transmission, you go to electrical distribution. Once transmission ends, at the consumer end, current is supplied to various consumers by overhead lines. These lines that you see coming close from your transformer to your house are called overhead lines. And these overhead lines, there are single phase lines and we have three phase lines. Single phase lines, you see 2 or 3 lines on the pole. In triple phase line, you see 3 or 4 lines in the pole. So in your house, you can look at the pole in your house, count whether it's 3 or 4. That tells whether it's single phase or 3 phase lines. Then now these lines will carry the electricity to your house. That is what? Distribution. Then when it goes to your house, you now look for electrical, you now come to an electrical connection. These distribution lines will carry the current to the point where this transmission and disposal line ends, and it will enter the consumer premises. The moment it enters the consumer premises, it will go to the consumer main terminal. This consumer main terminal is linked to the main fuse, which in local terms Electrical engineers locally call it cutout. But the technical name is what? The main fuse. From that main fuse, the now enters the actual link, which is the electrical energy what? Meter, that now regulates the current into your house. And you know, these days we have the analog meter that is being phased out, and we have the digital meter that the records pay as you earn. This is the basic way how electricity enter your house. When in our subsequent later, we now look at internal connections in your house and other electrical appliances and some of the electrical hazards within your house, which will take us to part 4 of this lecture. If you are thrilled by this lecture, as we say, click on red subscribe button. I am saying you are lecturer Agama, you Agama. Till we meet again. Thank you.